This core is 11 of 7, 49 of 10 west of the 5th, and it's just a few boxes from the Rock Creek member of the Fernie Formation. So it's Jurassic in age. It's been previously interpreted by, for example, Occitel as lower shore face to offshore sand sheets, and we've pulled these boxes because it has particularly good examples of Asterosoma and Diplocraterion, and many other traces that are labeled as well. But I wanted to use this little presentation to focus on the Asterosoma and the Diplocraterion. And in this image here, you'll see that we have Asterosoma, and the Asterosoma is defined by these causative burrows here. That's where the animal lived and probed. They often happen in sets because it's part of a radiating trace fossil. That's why it has the name Asterosoma. And then it has concentric reworking around the burrow. And this is really typical of Asterosoma. You'll also notice in this example some lined burrows that have show that encapsulate a relatively large diameter open burrow, and this is Ophiomorpha. It's just kind of a partially preserved lining, or the lining was never fully developed. There's other burrow mottling throughout here, and there's another Asterosoma here. And so on. It's a very distinctive trace fossil, and if you look at it otherwise, you can find Asterosoma in other outcrop locations. This is a Jurassic location here, not from Alberta, and you can see that these are the stellate probes that form Asterosoma here. So the causative burrow is somewhere in the middle of these, and then that concentric reworking occurs around them. And you can see that how it got its name Asterosoma stellate. When we have a core face, maybe we only cut through 2 or 3 of them. So all you ever see in core is 2 or 3 of these. There's other trace fossils in this core, and that includes, look closely up here, we'll have it labeled as Scaletia. It's basically a burrow where something like an urchin has burrowed through the sediment, and it passes sediment around its body and makes meniscae behind it. So this is the direction of travel for the urchin in this case. So we call that Scaletia. You can find the label there. And there's even something that I think is very challenging to identify here, which is Rhizocorellium, where we have 2 burrows and some reworking in between it, which is one of these kind of horseshoe-shaped burrows. It's a U shape that comes down and goes flat, and it has sprida or reworking around it. Now, that said, this Rhizocorellium, I'm a little uncertain of. I'm not entirely sure that's what it is, but I think that's how I would interpret it. And then, finally, there's another vague trace here that's probably defining Asterosoma. And you can see that sometimes identifying trace fossils requires a subtle eye. There's still large open burrows like the Ophiomorpha. This has a very poorly developed lining, so it could be an open branching burrow that we call thalassinoides as well. Those are normally made by decapod crustaceans. One of the other really amazingly displayed trace fossils in this core is Diplocraterion. And here you can see Diplocraterion. What is it? Well, simply said, it's a U-shaped burrow. And that U-shape has extended down over time. And you can see this is where the U used to be, then the U extended to here, and then the U extended to here, and so on. So This is really what we would think of as some type of uh, deposit or filter feeding burrow. It could be interface deposit feeding or filter feeding. And it's actually a really common trace fossil in lower shore face deposits, but you could have it in the proximal upper offshore as well. To explain Diplocraterion better, I found this great sketch by an ichnologist who works down in the U.S. His name's Tony Martin. He had this on Twitter, and he's like, oh, he's showing us the difference here between Diplocraterion, which are U-shapes, where the U has extended downwards over time. These are called protrusive. That doesn't matter. If it moves upwards over time, you can see the sprida are preserved differently, and those are called retrusive. And these are different than Arenicolites, which are just the simple U shape without the sprida. In other words, Arenicolites aren't showing adjustment or extension over time.